Okay, so today for a nice little introduction, we're going to focus on lists. So lists are quite nice in C# for a couple of reasons that we'll see in just a second. So we'll use the interface iList because we love interfaces, we love using them, and we'll make it an integer list. Now notice, even though I said there are no primitives in C#, notice that we don't have a separate int and big I integer object. So there's no need for us to box and unbox here, so that's lovely. So okay, we have our list int, we'll call it list equals new list int. Now it's worth pointing out that if we use var to qualify this, it'll make it a regular list. So I'm explicitly using an interface here. And actually, that's another time that I shy away from var, is when I want to use an interface specifically, but give it a concrete implementation on the right side. Okay, so this will create a new list and call it default constructor, yada yada. That makes sense, that's what we expect. A lot of console.read key down here, so we don't get out of hand. However, just like there were object initializers, we have something handy called collection initializers in C#. And what this does is it allows us to add 1, 2, 3, 4, 5 to the list, just like this, a bunch of literals, without having to call a .add method a bunch of times, in code. Now, note that this is exactly the same as in Java if we used the list interface. We made a new array list, and then we called add a bunch of times, so we add 1, add 2, add 3, add 4, add 5. This is doing the exact same thing. It's just a shorthand. So this isn't magically skipping the default constructor, that still happens here. It's not magically skipping an add and just shoving data in. It has to add all these, one by one. So keep that in mind when you're using this. This isn't a magic silver bullet to do whatever. So we can create a for loop, and these look just like they do in Java. We use count here. And one thing about all these sorts of homogeneous containers or whatever you want to call them, all these list alikes, all these collections, although we'll see why we don't want to use that term in a minute. They can all do count. Some of them have more specific things as well, like array has a length, I believe. So keep that in mind. I++. So count actually comes from, we see here, it comes from the iCollection interface. And we'll get more into that in a bit. So, okay, we can do console.writeLine, lists of I, and we'll see just like we expect, this prints out all of the contents of the list. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Perfect, just like we'd expect. Lovely. Okay, so notice we didn't use a list.get or a list.at. We just used a bracket like this was a regular array. Incidentally, if you want to do a char at a string, you do the same thing. C# allows us to do this because C# allows us to overload operators, and that includes indexers. If you think that it would be useful to overload an indexer for your class, go ahead and Google it. It's not very hard, it won't take you very much time. Very easy, very helpful. This is way, way more readable than a .get or .char at, in my eyes anyhow. So, as a general rule, like I always say, if you want to learn something new about C#, look at what ReSharper has to recommend to you. So this is going to tell us that we can convert this to a for each loop. So let's see what for eaches look like in C#. So as you can see, that's perfectly fine. Whew. We don't have a for and then a colon like we do in Java. We have a for each keyword. So this is some really nice readable syntax. So for each int t in list, we're going to write t. Very easy to read. With for each loops, it's actually quite common for people to put var here. So get used to seeing that a lot. In this case, it doesn't really add more information. I don't really like it because it doesn't make it explicitly clear that it's an integer. But, you'll see that a lot. Now actually, let's say we wanted to only print the even numbers. So let's say if t mod 2 equals 0. And we're going to put this right up here. So we're only going to print it if it's even. Okay, very simple, see? 2, 4. Those are only even two numbers in this list. Just what we'd expect. So, here's something fun. C# is recommending yet another thing, a link expression. Now, this is big and scary, right? So, what we can do, we're going to go back. This is what it looks like before. What we're going to do is we're going to learn link, and this is one of the extremely powerful parts of C#. And it uses extension methods which we're not going to get into, probably. While they are helpful, they're not so helpful that it's worth covering them at this stage. So we're going to create a var, and we're going to say even numbers. I'm going to say list dot. And if we scroll down, see all these guys with the little arrow next to them? These are extension methods. See, we can see the operator here as well. These are extension methods. These are things basically that allow you to add methods to whatever class you want. So it works on interfaces too. So these actually most of them all belong to the IEnumerable interface. There's an IEnumerable T. There's an iCollections T. And there's an iList. We also have iDictionary. This is what you would use if you wanted a hash map from Java. There is also I don't believe there's an iSet. There is a set though. I'll give it a T. There is a set. There is a queue. The set is a hash set. A queue is a queue like you'd expect. I don't think there's an IQ. Yeah, unfortunately not. So these are your basic guys you're going to use most often. So dictionary set and queue are kind of off on their own. iList extends iCollection. iCollection extends IEnumerable. IEnumerable does exactly what it sounds like. It allows you to enumerate over a collection. Now, don't get horrible flashbacks of, making an iterator or anything like that. You're not going to have to worry about that, really. But IEnumerable is the most generic type for this sort of thing. If you just want to be able to go over a collection and print stuff out or get data from it, you should try and use an IEnumerable interface if possible. iCollection adds the add and the remove method, so it lets you modify your collection a little. And the list adds yet more things, like the indexer, which allows you to grab elements at a specific position. So that's how all the interfaces work. All right. So actually, we're going to move on to link next time. So I'm going to stop here, and we'll cover link in the next video because it can be a little complicated. It can be a bit much to take in.